Hey everybody, it's Miss Berry. Today we are going to talk about confidence intervals, and specifically we're going to be going over confidence intervals whenever you are estimating population means. So a confidence interval provides us with a range of possible values that will estimate a population parameter with a specific level of confidence. Okay, so the population parameter that we're talking about in this video is a population mean. But you could also use a confidence interval to provide a range of possible values for something like a population proportion or a population variance. Now, specified level of confidence. They're going to tell you in the problem what confidence level that you want to use, but some common confidence levels that you'll see in scientific papers if you are reading or doing any research about, something related to your field of interest. The common confidence levels that you'll see are going to be 90%, 95%, and 99%, although in some of your homework assignments you may also see a confidence level of like 80% or 85%. Now, whenever you are using some of the formulas in this section, they are going to use the letter C to indicate the confidence level, and they are going to always refer to this confidence level as a decimal instead of a percentage. So 90% would be 0.90, 95% confidence level would be 0.95, and then a 99% would be 0.99. So just make sure that you are being careful to always use the correct value for C. Make sure it's in decimal form, not in percentage form. Okay, so the way that we construct a confidence interval for a population mean is we use the point estimate, which here would be the sample mean, and then we are either going to use the population standard deviation if we know it. That is sort of the ideal situation, is if you know the population standard deviation. But in real life, you often don't know the population standard deviation, and so we're going to look at how we can make some small changes and to our confidence interval and use the sample standard deviation instead. So we'll look at both scenarios, and the good thing about confidence intervals is that they're pretty easy to construct even by hand, but you can use your graphing calculator and it makes it super easy. It's just all you have to do is plug in the values and it's going to go ahead and give you the answer. So let's look at a little bit more information about how you would do this by hand. Now, before I talk about any specific formulas, I want to talk about something I mentioned on the last page, which was the importance of the standard deviation. A confidence interval, like I said before, for a population mean is constructed using the sample mean and either the population standard deviation or the sample standard deviation. If you do know the population standard deviation, then you will construct your confidence interval using the standard normal distribution. On your calculator, this will be referred to as a z-interval. So if you're copying down some notes as you go through this video, you may just want to write yourself a little flow chart here and say, starting at the top, if you're constructing confidence interval for a population mean, that's going to have two different little arrows coming off of it. You either know the population standard deviation or you don't know the population standard deviation. So if you do know the population standard deviation, you're going to do a z-interval. If you do not know the population standard deviation, then you'll construct your confidence interval using the student's t-distribution, which is, it looks very, very similar to the standard normal distribution. It's just slightly different, and this is on your calculator called a t-interval. Now, there's two different ways, like I mentioned before, that you can construct a confidence interval. You can either do it by hand using a point estimate and what's called the margin of error, and this just sort of gives you a little bit of padding on either side of that point estimate. And depending on your specified confidence level, like 90%, 95%, 99%. That'll determine how large or how small your margin of error is. But you can also do this really easily using your calculator. But you do have to have a graphing calculator for this, so your smaller Texas Instruments calculators or just a basic calculator is not going to be able to construct these confidence intervals. You have to have a graphing calculator. So let's talk about the margin of error, and at this point we're going to be talking about how you compute the margin of error if you know the population standard deviation. So again, the population standard deviation is denoted by the Greek letter sigma. So if you know sigma, then you know the population standard deviation. That's what it refers to. So when you're computing the margin of error, this is going to be referred to as a capital E. It's the largest possible distance away from the point estimate that a confidence interval will cover. And so that's like I mentioned in the last slide, or a few slides back. The margin of error is kind of like the padding around the point estimate. So it's going to provide you with the interval of values, or the range of values. And the higher your confidence level, the larger the margin of error is going to be. So it's going to sort of penalize you for that high confidence level, and it's going to inflate the margin of error. And similarly, if you choose a lower confidence level, it's going to cause the margin of error to get smaller. Now, whenever you know the population standard deviation, we construct the margin of error using critical z values, which are denoted by negative z sub alpha over 2 and z sub alpha over 2. So again, I'm saying z sub alpha over 2 because that alpha over 2 is the subscript. It's kind of hard to tell the way that it's written here because the little subscript is small, but it's also a fraction. But alpha over 2 is the subscript here. Now these critical z values mark the boundaries for the area under the standard normal curve that corresponds to a particular level of confidence. So if you imagine a normal curve, a level of confidence is going to be drawn by two lines on either side of that normal curve. And so you need a critical z value on each side of that standard normal curve. Now we're going to talk about alpha on the next slide and how you compute alpha. But don't let these critical z values worry you, because I know that they look a little bit complicated. But like I said, all of this information is really only important if you are constructing the confidence interval by hand. If you're using your calculator to construct the confidence interval, you will not need to manually compute the margin of error. Sometimes on the homework they'll ask you to compute the margin of error, but on the test I will not be asking you to do anything like that. Okay, like I mentioned on the last slide, critical z values help us construct the margin of error. And I told you that I would give you a little bit more information about what alpha was. So alpha is found by subtracting 1 minus c, where c is the specified confidence level. So here you see that I've drawn you a little picture, and this is our normal curve. You can see I've drawn a line on either side, and the area under the curve represents the specified confidence level. So here, the area under the curve would just represent c. So it could be like 0.90 if it was a 90% confidence interval, or 0.99 if it was a 99% confidence interval. And then your critical z values are going to be located at the endpoints of that specified confidence level. Now let's talk about how we compute these. These are going to be actual numbers. And you already know how to compute these. We learned this back whenever we learned about normal probability distributions. So I'm just going to review with you how we compute these critical z values. It says, suppose that we are constructing a 90% confidence interval. So here you can see I've drawn I've drawn a normal curve, and I've got the area under the curve labeled as C equals 0.90. That's because it's a 90% confidence interval. So what would alpha be here? So as we talked about a few slides back, we can find alpha by just saying 1 minus C. So 1 minus C would be 1 minus 0.90, so alpha would be 0.10. Now, we're going to use the fact that we know what alpha is to now compute these critical Z values. Now, since you can see the area that I've shaded in yellow here, that represents 0.90, so that's 90% of the area under the curve. That means there's 10% left. Now, that 10% has to be split up on both sides, so there's going to be 5% on the left side and 5% on the right side. And so that's where the alpha over 2 comes in. So alpha over 2 would be 0.05. So here you can see I've labeled my critical values, negative Z sub alpha, negative Z sub 0.05 and then Z sub 0.05. Excuse me, I think I might have said that last one wrong. Let me repeat it. The critical value on the right would be Z sub 0.05. Now I'm going to show you how you can use the inverse norm function on your calculator to compute these critical Z values. All right, so I'm going to start by just going to second and then vars. That's going to take me to the distribution list. Now I'm just scrolling down to inverse norm, and then I'm plugging in 0.05 because that's the area to the left that I'm looking for. So that's negative 1.64. Okay, so negative 1.64, that's my critical Z value on the left. Now, it makes sense that this value would be negative because you can see it's to the left of 0. All right, so if it's to the left of 0, think about a number line. If it's to the left of 0, that number should be negative. All right, so now let's find the critical Z value on the right. Now, I know that I have to add up a little bit. I have 0.05. Let me see, I'm going to draw here for you. All right, so we have 0.05. So 0.05 plus 0.90, that means the area to the left of this line would be 0.95. Excuse my bad handwriting, I'm using the mouse. So that tells me that the area to the left of this line right here would be 0.95 because that's 0.90 plus 0.05. And that's going to be important because whenever I'm doing the inverse norm function on a TI-83 plus, like you see on the screen here, it's going to require me to know the area to the left of the value that I'm trying to find. If you have a TI-84 plus CE, or just a TI-84 plus, then you will be able to select left, right, or center. Now let's go ahead and compute that critical Z value on the right. All right, so I'm going back to inverse norm. This time I'm doing 0.95. Close the parentheses. And there you have it, 1.64. So as you can see, these critical Z values are mirror images of each other. so now you can see I have labeled my critical z-values on the left and on the right, so negative 1.645 and 1.645. All right, so these are my critical z-values. These are going to help me construct my margin of error whenever I am constructing my confidence interval. Here are some common critical z-values for different confidence levels. So here you have an 80%, 85, 90, 95, 98, and 99. This will be provided to you on the formula sheet, so you do not have to have this memorized. So this will save you a little bit of time when you are working on these questions for confidence intervals. So it'll go ahead and give you the critical z-value. Here we have the formula for the margin of error. And again, this is if you know the population standard deviation. So the margin of error E is equal to the critical z-value, which is z sub alpha over 2, times the standard deviation of a sampling distribution of sample means, or sometimes called the standard error of the mean. And we know the formula for the standard deviation of a sampling distribution of sample mean is given by sigma over square root of n, where sigma is the population standard deviation and n is the sample size. So again, that comes from the central limit theorem. And this is the formula that you would want to use when you are constructing the margin of error. This formula will be listed on the formula sheet. Now we can look at the formula for constructing a confidence interval whenever the population standard deviation is known, so if you know sigma. Once you've calculated the value of the margin of error for a particular confidence interval, we're going to subtract the margin of error from the point estimate and then add the margin of error to the point estimate to construct the confidence interval. So you can see it's given as an interval here. It's got the little parentheses around the end, and we have the sample mean minus the margin of error, comma, sample mean plus the margin of error. So the sample mean here, x bar, represents the point estimate, and then E represents the margin of error. Now, this again is if you're constructing the confidence interval by hand. I'm about to show you how to construct a confidence interval using just your calculator. But before we start, there are a few things that you need to check before you start constructing your confidence interval. And these three conditions are specifically for a z interval. So again, a z interval is used when you know the population standard deviation. So the first thing you should check is that a simple random sample is being used. And again, if you remember, that was back at the beginning of the semester. That means that all possible samples of a given size have an equal probability of being chosen. You should also check and make sure that you know the population standard deviation. And then lastly, you need to check that either the population distribution is approximately normal or your sample size should be greater than or equal to 30. If these three conditions are satisfied, then you can go ahead and start constructing your confidence interval. Let's look at an example. An educational psychologist wishes to know the mean number of words a third grader can read per minute. She wants to make an estimate at the 95% level of confidence. For a sample of 835 third graders, the mean words per minute read was 24.1. Assume a population standard deviation of 3, and again, this would be 3 words per minute. Construct the confidence interval for the mean number of words a third grader can read per minute. And it says to round your answers to 1 decimal place. Okay, so a couple of important things here that we should remember. See that we have a 95% level of confidence. Our sample size is 835. Our sample mean, x bar, is 24.1. And then our population standard deviation, that sigma, is 3. Okay, let's get started. Here I've listed our important values. This is a 95% confidence interval. X bar, our sample mean, is 24.1. our population standard deviation was 3, and our sample size N was 835. So let me show you how to construct a confidence interval using your Texas Instruments calculator. You're going to click the Stat button, and then you're going to go over to Test. Now you're going to scroll down to a Z interval. Again, I'm using a Z interval because I know the population standard deviation. Now, here you can see it's giving you two options, data and stats. You're going to use data if you're given a set of data. And if you were, I'll show you an example of this in the population proportion video, but you would have to go into your stat list and put it into your L1 list if you had a set of data. Now we're just given some stats, so we're going to scroll to the right and select stats, and then just hit enter. That's going to bring up a different menu. So our population standard deviation sigma is 3. Our sample mean is 24.1. And you can just type right over anything that's in there. You don't have to delete it. Our sample size is 835. And then our confidence level, it's already in there. It's 0.95. So that was already in mine. You may have to type it into yours if it's not in there already. And depending on which calculator you have, it may give you a different option here. It may say something like paste. But here we have our confidence interval. It says Z interval 23.897, comma 24.303. And then it tells you the sample mean and the sample size. And if you recall, they told us to round to 1 decimal place. So that's going to tell us, pull that back up, pause that, and there we go. There's our confidence interval, 23.9. And again, if you remember, this is the number of words per minute that a third grader can read. So this would be 23.9 words per minute to 24.3 words per minute. And if you were interpreting this confidence interval, which I will ask you to do on the test, we would say we are 95% confident that third graders read, on average, between 23.9 and 24.3 words per minute. And just notice here that we need to say this part here, the on average, because we know that this is just an estimate. So this is just building around this point estimate of 24.1 words per minute. Now let's look at an example or talk a little bit about what happens when you don't know the population standard deviation. So let's talk about what happens when you don't know the population standard deviation. So as we just mentioned, one of the conditions of using the standard normal distribution is that we have to know the population standard deviation. And in real life, we rarely know the population standard deviation. And in fact, if you did know the population standard deviation, then that would indicate that you were that you would be able to also find the population mean. So you wouldn't need to construct a confidence interval. You would already know the population mean. So as a result, it's important that we thoroughly explore the next part of this chapter or this section, which is exploring the case of when we don't know the population standard deviation. And in that case, it's very important that we know two things. We need to know the distribution of the population and the sample size. Now, if either the population is normally distributed or the sample size is 30 or more, then we can use the student's t-distribution to calculate the margin of error for population mean when the population standard deviation sigma is unknown. Okay, so I just want to point out that the conditions here is you either have to have a population that's normally distributed, or you need the sample size to be 30 or more. Now, typically in the problem, they will either say, assume the population is normally distributed, or you'll notice that the sample size is greater than or equal to 30. So just pay attention to that as you're reading the problems. If you don't have those two things, then you wouldn't be able to use the student's t-distribution, and you would have to explore some more advanced statistical methods for constructing a confidence interval, which we will not get into in this class. Now let's talk about some properties of the student's t-distribution. First of all, it's a continuous probability distribution, so we've talked about discrete probability distributions and continuous probability distributions. This one is continuous. It looks very similar to the standard normal distribution, and in fact, if you had them right on top of each other like you're going to see in this next picture, they're almost indistinguishable. And the way that your book describes it is they say that the student's t-distribution has more area in the tails, which means the tails are a little bit, they call it fatter. So, but the difference here with the student's t-distribution is rather than being defined by a mean and a standard deviation, the student's t-distribution is solely defined by one parameter, which is called the degrees of freedom. Now, the degrees of freedom are based on your sample size. And as you can see here, they're abbreviating degrees of freedom with DF. Now, we could talk more about the degrees of freedom, why they're called degrees of freedom, but for the purposes of this class, what you should know is that the degrees of freedom are determined by the sample size, and the way that you determine the degrees of freedom is the degrees of freedom is equal to the sample size minus 1. And as we know, the sample size is represented by the lowercase n. Now, I wanted to pull up this picture again and just point something out to you. The student's t-distribution, as I said, is defined by its degrees of freedom. And the more degrees of freedom you have, the closer this curve is going to get to the standard normal curve. So as you can see, the blue curve here, that's degrees of freedom equals 14, so that means you have a sample size of 15. And the green curve here, you have degrees of freedom equals 3, so that means your sample size is 4. Okay, so that's notice how the blue curve is getting closer, it's approaching that standard normal curve. So as you increase your sample size, this student's t-distribution is just going to get closer and closer to the standard normal distribution. Now, there's no standard t-distribution that we can use to compare probabilities the way that there was with the standard normal distribution. Now, we can do two things. We can either use the table to look up critical t-values. So whenever you're calculating the margin of error, you'll need to use critical t-values, very similar to how we did with the standard normal distribution. But if you have a TI-84 or newer, so if you have like the TI-84, TI-84 Plus, TI-84 Plus Silver Edition, or a TI-89 or TI Inspire, then you can use your calculator to calculate these critical t-values. And then certain Casio calculators can also calculate the critical t-values. Now, unfortunately, I don't have a Casio calculator emulator that I can show you how to find these critical t-values, but if you do need some help figuring out how to look up critical t-values with your calculator, then you can always email me and I can help you find some videos or find some PDFs to help you figure out how to do that. So I'm going to show you both methods. I'm going to show some examples where I use the table, and I'm going to show some examples where I use the calculator. Now, of course, the calculator is probably going to be easier just because you won't have to use anything extra, but I will provide the tables for you on the quiz. Now let's look at an example. It says find the value of t sub 0.05 for the t-distribution with 50 degrees of freedom. Okay, so the way that they have it indicated here, we have t sub 0.05, so that's going to be the area in one tail. Now I have a little screen recording here to show you how to use the table to look up the critical T value. And notice that it has 50 degrees of freedom. In this table here, this will be the exact table that's provided to you on the quiz. So we have the area in one tail, and then underneath here we have area in two tails. So that'll be specified in the problem if it is area in two tails. If it's not specified, you can assume that it's area in one tail. And then on the left here we have the degrees of freedom. Notice that this is the degrees of freedom and not the sample size. So make sure that you're using the correct information whenever you use this table. Okay, so area in one tail was 0.05 and the degrees of freedom is 50. So let's look up how to, or let's watch this short little clip on how to use the table. All right, so there we go. There's our area on one tail, 0.05. Now I'm just going to scroll down the table. My computer was working really slow today, so that's why it's kind of lagging. You can see the pictures are lagging on the right hand side. And there we have 50 degrees of freedom. So we're just going to find the intersection of those two, that row and that column, and there is your T value. So there's your critical T value, 1.676. Let's look at an example where we find a critical T value using the calculator. The question says, find the value of T for the T distribution with 25 degrees of freedom such that the area under the curve to the right of T equals 0.010. Round your answer to 3 decimal places if necessary. Now, what you're going to see in this example as we use the calculator is that by default, your calculator is going to expect you to input the area to the left of T. And since our example gives us the area under the curve to the right of T, we're going to have to do 1 minus that area so our calculator knows the area to the left. All right, so let's look at how we use the calculator in this example. All right, so as you can see, I just went to second vars. That's going to take you to the distribution list. Now you're going to scroll down to inverse T. Now, if you have the TI-83, you're going to notice that you don't have this option. If that is the case, then you will have to use the table. But if you have a TI-84 or above, or like I said, if you have a Casio that can do this, then you have the option of either using the table or using your calculator. So again, I went to second vars, and now I'm going to scroll down to inverse T. And I'm going to hit enter. My calculator wants to know the area to the left. So I'm going to do 1 minus 0.01. Now you can put it in your calculator just like that. Your calculator will simplify it for you. So 1 minus 0.01. And then the degrees of freedom is 25. They tell us the degrees of freedom in the problem. And then I'm just going to hit paste and hit enter, and that's going to run it. Now, it will take your calculator a second to compute this value, and there you go. It's 2.485. That is your T value. Now I want to show you an example where it's asking for the area to the left and the area to the right. So it says finding critical T values, find the value of T for the T distribution with 11 degrees of freedom such that the area to the left of negative T and the area to the right of T equals 0.05. Now, this is pretty easy to do with the table since they tell you your table here is broken up into area in one tail and area in two tails. We can just use the area in two tails row. So we're going to start here with area in two tails is 0.05, and we will scroll down our table to where we have the 11 degrees of freedom. So here you can see I'm highlighting or I'm indicating the column that I'm going to be using, 0.05, and then 11 degrees of freedom. My computer was working really slow today. And then I am just finding the intersection of those that column and that row. And that tells me my critical t-value. So my critical t-value is 2.201. Now I'm going to show you how to do this exact same problem using your calculator. Again, the problem says find the value of t for the t distribution with 11 degrees of freedom such that the area to the left of negative t and to the right of t equals 0.05. Round your answer to 3 decimal places if necessary. Now we already know that the answer should be t equals 2.201. That's what we found on the last slide. So let's make sure that our calculator gives us the same answer. We're going to start off just like we did before. We're going to parse. That's going to take us to the distribution list. Now we're going to scroll down to option number 4, which is inverse t. Now let's talk about what we're going to put in for the area to the left of our t value. Again, by default, your calculator is looking for the area to the left of that t value. So, since we know that there is 0.05 in both tails, that means that it's 0.05 divided by 2 in each tail. So there's going to be 0.05 divided by 2 in the left-hand tail and 0.05 divided by 2 in the right-hand tail. So to find the area to the left of my tail that's on the right-hand side, I'm going to do 1 minus, again because it's the area to the left, 1 minus 0.05 divided by 2. Now, you could easily draw yourself a picture and figure this out, you know, if that makes more sense. I typically draw a picture every time I do these problems. So 1 minus 0.05 divided by 2. That's going to tell me the area to the left of that tail on the right-hand side. Degrees of freedom is 11. Now I'm going to go to paste, and again, once you get to this screen, you're just going to hit enter, and your calculator will take a second to run this. And there you have it, 2.201 if we rounded to 3 decimal places. Now, like I said, if you have a TI-84, you can choose to either use the table or you can use your calculator to find these critical T values. If you have a TI-83 or if you have a Casio calculator that does not find critical T values, then you can use the table. The table will be available on each relevant quiz question. Now, this formula should look somewhat similar. It looks very similar to the margin of error formula whenever we knew this population standard deviation. This one's just a little bit different. It says the margin of error E is equal to our critical T value, T sub alpha over 2, times S, the sample standard deviation, divided by the square root of N, where N is the sample size. Now, some of your quiz questions, sorry, not your quiz questions, your homework questions will ask you to find the margin of error. But typically I wouldn't put a question like this on the quiz. This formula should also look similar to you. This is the formula for constructing a confidence interval whenever you do not know the population standard deviation. So if you're constructing these confidence intervals by hand instead of using the calculator, this is the formula that you would use. The left endpoint would be the sample mean minus the margin of error. Your right endpoint would be the sample mean plus the margin of error. Again, our sample mean X bar is our point estimate, and E is our margin of error. Now let's look at an example of constructing a confidence interval. This is going to be the easiest problems on the quiz because all of this can be done in your calculator. It says, in a random sample of 26 residents of the state of Montana, the mean waste recycled per person per day was 2.8 pounds with a standard deviation of 0.23 pounds. Okay, so we're looking at the amount of waste that a person is recycling every day. It says determine the 80% confidence interval for the mean waste recycled per person per day for the population of Montana. Assume the population is approximately normal. So that is an important point here. Assume the population is approximately normal. Remember, in order for us to use the student's t-distribution, we had to know one of two things. We either had to know that the population was from a normal distribution, or we had to have a sample size that was 30 or larger. Since our sample size here is less than 30, then it was absolutely necessary that we know that the population is approximately normal. Now, some other important things here. We know our sample size is 26. We know our X bar, our sample mean, is 2.8. And we know our sample standard deviation, S, is 0.23. So, step one is to find the critical value that should be used in constructing the confidence interval. And again, this would really only be important if you were doing this by hand. If you're using your calculator, you're not going to have to find the critical value, but some of the homework problems may ask you to do this, so I'm going to show you how to do it. So, important points. We know we're doing an 80% confidence interval. We know that our sample mean is 2.8. We know that our sample standard deviation, S, is 0.23, and we know our sample size is 26. Now, whenever we're finding the critical t-values, instead of knowing the sample size, they want us to tell them the degrees of freedom. So the degrees of freedom here would be 26 minus 1, which is 25. So it's always the sample size minus 1. Now here's our 80% confidence interval. Again, this looks very similar to those normal distribution problems that we did earlier in this video. So the area in the middle of the curve that we're looking at is our confidence level is 80%, so that's C equals 0.80. That tells us that the area in the two tails is 0.20 because all of the area under the curve has to add to 1. So since we know the area in the two tails is 0.20, that tells us that half is going to be in the left tail and half is going to be in the right tail. So that tells us that the area in the left tail would be 0.10, and now we can find the area to the left of that t-value that we're looking for. So the area to the left is going to be 0.80 plus 0.10, which is 0.90. Now we can look up the critical t-value. So it says find the critical value. Now let's go ahead and start. We should be pretty good at this by this point. We've done several examples. We're going to second bars. We're scrolling down to inverse t. Then we're going to put in the area to the left, which we just found was 0.90 or 0.90. And we know that our degrees of freedom was 25 because our sample size was 26. So we're going to paste that into it. We're going to hit enter. Our calculator is going to take a second to compute the value. And there you have it. Our critical t-value is 1.316. Now let's complete step 2, which is to construct the 80% confidence interval. It asks us to round our answers to 1 decimal place. So let's look at how we construct the confidence interval using the calculator. Of course, if you are constructing the confidence interval by hand, you would need to calculate the margin of error using that critical t-value we just found and plugging it into that margin of error formula along with the sample standard deviation and the sample size. It's a lot easier if you just use the calculator, which is what I'm going to show you here. These steps are going to look similar to what we did in the beginning of the video with the Z interval. So you're going to go to the stat, go over to tests. Then you're going to scroll down to option number 8, which is T interval. Hit enter. Then you're going to have two options. You have this data option and the stats option. You only use the data option if you are given a set of data. If you are given statistics like the sample mean, the sample standard deviation, then you will go and scroll over to the stats option. So I'm arrowing over to stats, and now I'm going to enter in the sample mean, which was 2.8. The sample standard deviation, which was 0.23. And the sample size, which was 26. Notice that they're asking for the sample size and not the degrees of freedom. Okay, so just be careful whenever you're plugging in that in, and make sure that you're using the sample size, not the degrees of freedom. Now they're asking for the confidence level. This is an 80% confidence interval, so it's 0.80. Then we're going to go down to calculate and hit enter. This is going to automatically compute your confidence interval for you. So here we have, it says round your answer to 1 decimal place. So our confidence interval is going to be 2.7 to 2.9. And then if you are asked to interpret the confidence interval, which I will do on the quizzes, then you would say, we are 80% confident that in Montana, the mean waste recycled per person per day is between 2.7 pounds and 2.9 pounds. So I just want to point out that whenever you are constructing these statements at the end, you want to include a few important things. So you want to make sure you include the confidence level. You want to make sure that you're including the, in context, what your confidence interval refers to. So here it was the mean waste recycled per person per day. And then you want to make sure that you use the numbers in context. So include those units. So 2.7 pounds and 2.9 pounds. The last example that I'm going to go through is where you have to construct a confidence interval and you're given a set of data. This example says, the following is a random sample of the annual salaries of high school counselors in the United States. Assuming that the distribution of salaries is approximately normal, construct a 99% confidence interval for the mean salary of high school counselors across the United States. Round to the nearest dollar. Okay, so that tells us we're going to round to the nearest whole number. So a couple of important things I wanted to point out here. Notice that we only have data for 1, 2, 3, 4, 5, 6, 7 high school counselors. That is definitely less than 30, but it's okay because they told us that we can assume that the distribution of salaries is approximately normal. If they had not told us that, then we would not be able to use the student's T distribution to construct this confidence interval. They also tell us that we're supposed to be doing or constructing a 99% confidence interval here. So here's what you're going to do. You're going to get your calculator and you're going to go to stat, and then you're going to enter in these numbers into your list. All right, so keeping in mind that we are constructing, a 99% confidence interval, we're going to start by going to stat. Then we're going to go to edit. If you have anything in your list, you should go ahead and clear it out. My list is currently empty. Now I'm going to type in all of my data points. You're going to want to be very careful and make sure that you plug these all in correctly. If you mess up on even one of these, on just even in the slightest bit, it's going to throw your answer off. So always double check after you've typed everything in. And here's my last one. Now you're going to go back to stat, then scroll over to tests, and then you're going to scroll down to option number 8, which is T interval. Remember, you're going to do a T interval if you do not know the population standard deviation. Hit enter. This time we have a set of data, so we're going to scroll over to data and hit enter. Make sure that L1 is, make sure that you have the correct list here. So my information or my data was in list L1. Frequency should remain at 1, and then you're going to make sure to put the correct confidence level in. Our confidence level was 99%, so 0.99. Then go down to calculate and hit enter. Again, it's going to immediately calculate your confidence interval for you. And there it is. So it's already rounded to the nearest whole number for us. So it's $31,974 to $57,817. And if we were interpreting this, we would say, we are 99% confident that the annual salaries of high school counselors in the U.S. is between $31,974 and $57,817. Now you've covered everything that you need to know about constructing confidence intervals for population means. In the next video, I'm going to talk about constructing confidence intervals for population proportions. Please let me know if you have any questions by emailing me at jberry@ccga.edu.